Hello everyone, myself Vinay Kumaram. I am actually pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in this particular video, I'll be teaching the third chapter of science subject in 9th standard. This is a very interesting chapter which is based on atoms and molecules. So in this particular chapter, let us learn what do you mean by atoms, what do you mean by molecules. So everything related to atoms we will be learning in this particular chapter, and in the next chapter, that is chapter 4, you will be learning structure of atom, where you will be learning what is there inside atoms. So coming to this particular chapter, you might be seeing lot of matter around you. So we have discussed matter in our surroundings. We have also discussed is matter around us pure. So these were two chapters. So there we have discussed lot of things about matter. So how this particular matter came into existence? So what is the building block for this particular matter? So what are all composed together to form this particular matter? So let's suppose say I have this particular pen. So what this particular pen consists of? Because there might be something which has got constructed inside this particular pen, so that finally we got this particular pen. So what is that? So when you actually go on dividing this particular pen, you will get different compounds, you will get different elements, and finally you will get atoms. So in ancient India, that too in BC, in 500 BC, there was a Maharishi called Kannad. So this particular Maharishi Kannad came up with a theory where he told when you actually divide a particular matter, when you go on dividing matter into smaller parts, you will reach that final particle where you cannot divide that particular particle further. So that particular final particle, he named it as Paramanu. That is what atoms. So similarly, there was one more Indian philosopher whose name was Pakuda Katyayama. So this particular Indian philosopher also put forward that these particular atoms or these particular Paramanus will combine together to form different kinds of matter. Hence we can see variety of matter around us. So he actually came up with the theory of compounds, where Maharshi Kannad came up with the theory of Paramanu or atoms. Parallelly, in Greek, there was a philosopher called Democritus who actually coined this particular word atom. So atom means indivisible particle which cannot be further divided into another particles. So all these explanations what I have given now are all just theories. They are all just theories made by philosophers. There is no vigorous experimental evidence for these particular theories. So whenever there is a theory, so that theory should be tried and tested in all experimental modes and come to a conclusion. Only when you get certain experimental evidences that yes, this is true, that these particular atoms cannot be further divided. So only when that is confirmed through experimental pathways, till that you cannot come to a conclusion. Even after coming to a conclusion, there might be breakage of that particular conclusion, or that conclusion might lead to new theories as well in future. So that's why these are all just theories which were given by philosophers. There was no proper scientific evidence till 18th century. So after 17th and 18th century, there were so many scientists, chemists and physicists who came up with different theories with different experimental observations. So based on that particular experimental observations, they came up with theories, and that particular theories actually gave much more clarity about understanding what are all atoms are. So we will go on learning different concepts which are related to this particular chapter. So now let us do one particular activity so that we can understand much more about different kinds of laws which are actually established in this particular nature. So now you take sodium carbonate in a conical flask and place one particular test tube inside this particular conical flask in such a way that the chemical which is put in this test tube is not mixing with this particular chemical which is there in this particular conical flask. So in this conical flask, if you take sodium carbonate and if you take copper sulfate in this particular test tube, now seal this particular conical flask with a rubber cork so that no gases will be coming out from that particular conical flask. Now you just weigh this particular total mass of this setup. So you will get a particular mass. Now you just tilt that conical flask a little bit so that whatever solution or the sample which is there inside this test tube will fall into this particular conical flask, so that there will be reaction occurring between sodium carbonate and copper sulfate. Now after this reaction is complete, again you weigh this particular setup. Don't open that particular rubber cork. After the chemical reaction is over, you can weigh this complete setup. You will see the mass remains same. That shows even after chemical reaction, there is no change of mass. This is actually known as law of conservation of mass. So this is one important law in the nature which has got established, where even after chemical reaction, there is no change in mass of the total mass of that particular setup. So that shows the total mass remains same. Why we are actually closing this particular conical flask with rubber cork? Let's suppose say in some chemical reaction, if gases are evolved, that particular gases will get escaped out of conical flask and there might be reduction in mass, because gas also contains elements and compounds in it. So that also has some mass. So if you let gas to go out, then mass will be reduced. So that's why you should trap that particular gas which is evolved during chemical reaction inside that conical flask itself. That shows even after chemical reaction, the mass of the total mass of the system remains same. That means mass cannot be created, mass cannot be destroyed. So you should remember this particular statement. Mass cannot be created or destroyed. So mass cannot be created or destroyed. So this is actually law of conservation of mass. So where that particular mass has went, so the one particular solution will be having certain mass and the other particular solution will also be having certain mass. When you actually make a chemical reaction between these two solutions, so at that particular time there will be chemical reaction between these two solutions or these two compounds, and the mass of that final compound will be the sum of the mass of whatever the initial precursors was. So this shows that law of conservation of mass is there even in the chemical reaction. So coming to another particular concept in this particular chapter, there was a scientist named Lavoisier who actually defined law of constant proportions, or it is also known as law of definite proportions. So what do you mean by law of constant proportions? So in nature, elements will combine together to form compounds, and this particular compounds will have the elemental composition same throughout that particular compound, irrespective how it came to that particular existence. So for example, now if you are considering water as a particular compound, here two elements have got mixed in this particular water. One is hydrogen and the other element which has got combined in this particular water is oxygen. So there is a bond formation between hydrogen and oxygen. So there is a compound formation between hydrogen and oxygen. So in this particular water, two hydrogen atoms combine with one oxygen atom and they form a particular compound, that is water, that is H2O. So now this particular H2O will be having same chemical composition throughout that particular water. It will not change anywhere. So when you consider this particular H2O molecule, this particular H2O molecule, if you take mass of this particular H2O molecule, always mass of this hydrogen is to oxygen will be 1:8 ratio only. So for example, if you take 9 gram of water, in this particular 9 gram of water, 1 gram will be hydrogen, 8 gram will be oxygen, because mass of one particular hydrogen is 1 atomic mass unit, that is 1 AMU. So in future you'll be learning what you mean by atomic mass unit, and mass of this particular oxygen is 16 AMU, that is 16 atomic mass unit. So here you can clearly see one particular H2O molecule contains 2 hydrogen. So 2 hydrogen means 2 hydrogen together forms 2 AMU mass, and 1 oxygen will have 16 AMU mass. So now if you take ratio of this 2 and 16, so 2 divided by 16 will be 1 by 8. So this particular ratio is maintained throughout that particular water. That means there will be no H3O3 or there will be no H3O or there will be no HO3. So like this composition will not be there. Throughout that particular water, it will be H2O combination only. So how you got that particular water, it doesn't matter. So once the water is formed, once the compound is formed, the composition will be fixed throughout that particular compound. So here H2O is one particular compound. So throughout that particular water, throughout that particular compound, H2O will only be there. That to 1:8 ratio of hydrogen mass and oxygen mass will be there. So if you consider the mass of that particular elements, then hydrogen and oxygen will be in the ratio of 1:8. So this is the mass ratio of hydrogen and oxygen in water. So this particular ratio is maintained throughout water and H2O combination is maintained throughout water. So this particular theory is actually known as law of definite proportions, or this particular law is also known as law of constant proportions. Why they gave the name constant is because this particular compounds, whatever compounds you take in nature, they have all formed with elemental composition. So that particular elemental composition which is there in a particular compound will be maintained throughout that particular compound. So if you consider water for example, then H2O will be there throughout that particular water. Wherever you take water, through whatever mode that particular water has got formed, still the composition of water will be fixed. That is H2O, and the mass ratio of hydrogen and oxygen will be fixed throughout that particular water. It doesn't change. So that's why law in this particular nature is known as law of constant proportions or law of definite proportions. So the first law which we decided was related to mass, that is law of conservation of mass. And the second law which we have studied is also related to mass. The mass of individual elements in that particular compound will maintain the same ratio throughout that particular compound. So this is also related to mass of that particular compound. So to understand this particular laws which was established, there is law of conservation of mass and law of constant proportions. Dalton came with a particular theory. So he came up with postulates, and that particular postulates was established to understand the law of chemical composition. So these basic laws of nature was better explained by Dalton. So Dalton actually came up with this theory and he stated few postulates in that particular theory. That particular theory is known as Dalton's atomic theory. So now let us discuss what do you mean by Dalton's atomic theory. So here also Dalton took the same idea of Greeks like Democritus who coined the name atom. So he also took this particular name atom in his postulates, whether it might be a element or compound or any matter will be made up of small indivisible particles. So all this particular element, compound, matter are all made by a small indivisible, that is further division cannot be made. So here also this particular theory emphasizes that atoms are the final particles in a particular element or a compound. So here also he used the same term which Democritus used, that is atoms. So these atoms are the building blocks of this particular element, compound or any matter, and these particular atoms are further indivisible. So this is what first postulate states. So second postulate was atoms cannot be created or destroyed. So atoms cannot be created or destroyed in a chemical reaction. So if you take any kind of chemical reaction, in that particular chemical reaction atoms will be involved and this particular atoms will not be created or destroyed. So they will remain. So after this there might be different compound formation or there might be reduction in the amount of atoms which are present in the elements by forming new compounds. But there is no destruction of atoms as such and there is no creation of atoms as such. So that shows atoms cannot, this is just a postulate, this is just a theory given by Dalton. So but till this particular point everybody believed that atoms are indivisible particles and further atom cannot be divided. So in the second postulate Dalton explains that atoms cannot be created or destroyed in any chemical reactions. Coming to the third property, if you consider a particular element, then atoms of that particular element will have same identical mass and identical chemical behavior. So for example, we take sodium for example. So if you take sodium metal as such, so now you have sodium element, and this particular sodium element is made up of so many sodium atoms. So all these sodium atoms, so that is Na atoms, will be identical in nature and identical in mass and also identical in chemical behavior. So there will be countless number of sodium atoms come together to form a particular big sodium element. So in that particular element, which are made of same atoms, so all those same atoms will have identical mass, identical chemical behavior. Same atoms will be there in a particular element. So if you just consider sodium, then all the atoms in that particular sodium will have same nature, same chemical behavior, same mass. This is actually the third postulate of Dalton. So fourth point is also related to third point, because in third point, if you are considering atoms of same element, then that particular atoms are same and identical and have same chemical behavior. But in fourth postulate, if you are considering atoms of different elements, so if you are considering atoms of different elements, then that particular atoms will have different chemical behavior and different mass. For example, if you are taking one particular atom from lithium, that is lithium atom, and if you are considering another particular atom from sodium, that is sodium atom, and if you are considering lithium atom with sodium atom, then there will be surely chemical difference between lithium and sodium. That means from two different elements you are taking atoms and you are comparing those two atoms. So obviously there will be difference in mass of this particular atom and this particular atom, and also there will be difference in the chemical behavior of this particular atoms. So if you consider atoms of same element, let's say if you are taking just sodium and if you are comparing atoms of sodium, then atoms will have same mass and same chemical behavior. But if you are considering atoms of two different elements or different elements altogether, then atoms of each element will be having different mass. So this is actually the fourth postulate of Dalton. So coming to the fifth postulate, atoms will actually combine with small whole number ratio. So atoms combine with small whole number ratio. So what do you mean by small whole number ratio? So here half atom or 1/4 of an atom will not involve in any particular chemical reaction or in any particular compound formation. So full atom will be actually involved in a particular compound. So for example, if you consider water as your example, so here water contains two hydrogen atoms and one oxygen atom. It doesn't contain one hydrogen atom and half oxygen atom. So half oxygen atom or half hydrogen atom cannot be there. Always atoms will combine in a whole number itself. So that's why here whole number is very important, because you can clearly see here 2 is whole number, here oxygen is just 1. So 1 is also a whole number. So all these atoms combine in this particular whole number ratio. They will not combine in any other decimal number ratio. Here in water we know that H2O means 2 hydrogen atom will be there with 1 oxygen atom. So you cannot write as HO.5. This is wrong, because here you can clearly see ratio is matching, because here 1 hydrogen atom is there with half oxygen atom. So ratio of the mass of this particular elements might be matching, but this kind of atoms cannot exist. That is, half atoms cannot exist in nature. So that's why they will always combine as a whole number ratio, that is H2O. So this is what the fifth postulate of Dalton's theory explains. Coming to the sixth postulate, here Dalton explains that the relative number and kinds of atoms are constant in a particular given compound. Relative number and kinds of atoms will always be constant, means the number or the proportion in which that particular atoms are arranged will remain throughout that particular compound, and also the same atoms will be there throughout that particular compound. So for example, if we consider water as a compound, here two hydrogen atoms will combine with one particular oxygen atom. So this particular relative number will be maintained throughout that particular water, and also atoms which are actually responsible in forming water will be always hydrogen and oxygen itself. There will be no other element combining with this particular hydrogen and oxygen to form water, because water will always contain hydrogen and oxygen. Only in a definite ratio when oxygen and hydrogen combines, then only there will be formation of water. Other than that, water will not be formed. So this particular relative number and kinds of atoms which are actually involved in forming a particular compound will be fixed, will be constant. So here, what do you mean by relative number? So if you consider water, H2O is a particular chemical formula of this particular water. So what do you mean by relative number in a particular compound? So relative number is that particular number which gives you the percentage of a particular atom or a particular element in that particular compound. So for example, if you are considering water as a compound, how much percentage of hydrogen is there? So how much percentage of hydrogen is there and how much percentage of oxygen is there? So this particular percentage ratio or the percentage of different elements in a particular compound will be constant throughout that particular compound. So here, if you are considering water, how much amount of hydrogen will be there and how much amount of oxygen will be there, so that will be responsible in the formation of water. So that particular percentage of hydrogen and that particular percentage of oxygen will be maintained throughout that particular water. Only then water will be formed. So if you consider water as a compound, the relative number, so relative number is actually the percentage of individual elements of that particular compound. So that will be fixed throughout that particular water. That means H2O will be maintained throughout that particular water, and the kinds of atom, that means only hydrogen and oxygen will come together to form water. So basically what this particular sixth postulate states is that relative number of a particular compound and kinds of atoms which are actually involved in that particular compound will be same throughout that particular compound. So here water is just an example. If you take any compound, the ratio of that particular elements which have got combined to form that particular compounds will be maintained throughout, and also the relative number of that particular, that means the percentage of elements present in that compound will be same throughout that particular compound. So this is actually sixth postulate of Dalton. So this is all there in this particular video. So the further concepts which are there in this particular chapter I'll be uploading in subsequent videos. So like this, if you want to learn more physics, chemistry and mathematics, then please do subscribe to my channel and stay tuned with my channel. Thank you.